So we want to look how to connect an LED to the ESP32, but first we look how to connect an LED to make it light. So we start with what is the symbol for a LED we would use in a schematic. So this symbol in a schematic for an LED is this. It's a diode with two arrows that indicate that light is emitted. What else do we need if we want to build a circuit with an LED? We need a resistor to limit the current that goes through the LED. And this is already the first schematic we have, which we then will be built up as a circuit. So the LED has two different sides, and we can see this here. There are two legs of different length. And here we have also two sides. This side is the side which we call minus or ground or 0 volt. This side of the LED, and also then on this side we have plus. In our case this is 3.3 volt, in other microcontrollers maybe 5 volt. The resistor can be on this side of the LED or on the other, it doesn't matter. We just have to have it in a row with the LED in order to limit the current that goes through. Now, in order to know what resistor we have here, we have to look a little bit further. So let's have a look at a data sheet. I've got one data sheet here open. And if we look here, it's an LED, 5 millimeters, that's the diameter. And there are different information pieces, so the reverse voltage. So if we put the LED the wrong way around, if we would turn it around, if here would be plus and here would be minus, it would not work. This is sort of the reverse direction. There would be nearly no current, just a few microamps flowing, and we would not see anything. And then there is what temperatures it can be operated in, also at what temperature it can be soldered. But what's more interesting for us now is the electrical information. So what information do we need here? So there is the recommended operating current, this one. And this is in our case 20 milliamps. So I write this down. I stands for current, is 20 milliamps, and 20 milliamps is 0.02 amps. And now at what voltage is the LED operating? And what it says here, the forward voltage is typically 2.1 volt. And this means whatever voltage we have in our whole circuit, between those 2 points we have 2.1 volt. And now it's fairly simple. If we have in total 3.3 volts, we have here 1.2 volts. And now we know U for our resistor is 1.2 volts. And as you may remember from high school, the resistance is U divided by I, in our case 1.2 volts divided by 0.02 amps. And I just put it in the calculator to be sure to make no error. And what we see here, 1.2 divided by 0.02 is equal 60. So this means if we have a resistor of 60 ohm, we would have 0.02 amps, like 20 milliamps, going through the resistor at 1.2 volt, which then would have also 20 milliamps going through the LED. So this is the easy calculation. Now if we look at some more details in the data sheet, we see it doesn't really matter how precise we are with our resistor if we don't have a given intensity we need. So I think for prototyping, you can be very sort of a bit up, a bit down, doesn't really matter. And so you see here sort of the forward current that can be between here, it will already light up at 5 milliamps and all the way up. And so we see also then the voltage changes. So here, whether you use 60 ohm, 50 ohm, 100 ohm, it will work fine for your prototype. If you have a production system, you really think carefully about those things. But for prototyping, if you don't have exactly this value, it doesn't matter. Going up and down will only change how bright your LED looks like. So now what do we have? We have an LED, and I have already a resistor that's fitting. And now let's have a look if we can connect it. And I'm not programming the microcontroller yet. I'm connecting it to where we have 3.3 volt all the time. So if we look here, it shows what pins we have, and the first pin is ground and the second pin is 3.3 volts. So what I do is I connect it with the long side, which is the plus, and it's easy to remember. Long plus has 2 dashes, minus has 1 dash, so the long side is plus. So I connect this to 3.3 volts. The other side I put into an open field, and I connect the open field, which I have here, where I have the LED with ground. And what we see is our LED is constantly on. I just connected the LED, and basically this is sort of the circuit we're seeing. Now this is not completely exciting, but just two more things. What happens if we put the LED the other way around? I said already, it doesn't do anything. So if we put the LED the other way around, so we can see nothing. This is sort of not the forward direction, but if we turn it around in the forward direction, we see the LED is on. Now we have here a pin that's constantly on. The next step is to look for a pin that we can switch on and off and build up the same circuit. So we don't connect to a constant 3.3 volt. We connect to something where we can either say this is 0 volt or this is 3.3 volt. Now, if we look at the LED, now it's connected to 3.3 volt. Now, we can have a look at our data sheet. I have a printout of the data sheet here, and we see that, for example, pin 25 here and pin 26 can be used. And so let's have a look and log on to our microcontroller, to MicroPython, to try it out. So what I do is I first build our schematic. So here ground stays, but on this side I don't connect it to plus as I had it. I connect it to what we call GPIO, that's sort of general purpose input output number 25. So I do that. I'll look here. Again, 25. And then I connect the open side, connect the resistor to ground, and the LED is off. This can be on and off. We don't know really what the status is of the pin, so in this case it's off. But now let's go to our web console. Here now we have to look. It says on top the address of our microcontroller is 192.168.2.150. So I change this. And let's see if we can connect. It asks for a password, and we even have it here on the screen. The password is test in our web console. And we can use the console to directly operate there. And now the first step, and this is fairly straightforward, is that we look at we need to use the pins. Now what we do is we import from pin, because we need the pin, and now we say P25 is equal pin, and which pin is it? It's pin 25, and we want to have it as output, and output is all uppercase. And now once we switch it to output, it's already on, and now we can switch it on and off. So let's try this. So we say P25, which was our variable, and we say off. So you can see it's off, and now we can say P25, and we say on, and we see the LED is on. Now, what else can we do? So we have now the LED switched on and off. Let's import something else. Let's import the sleep functions from time, import sleep. And once we have the sleep function there, we can now make a loop where we switch on and off the LED. And this looks like this. We have a loop which we will run forever, so while true. And now we can say switch the LED on, so P25 on. Then let's sleep for 1.5 seconds. Then we say P25 off, so we switch it off, and we sleep for half a second, and that's already it. So let's see, if we run this, we should see that the LED is on and off, but longer on than off. And the nice thing is we can interactively develop this. So we have now an LED blinking. Now what is interesting, we can use the same thing, but be much faster and can start changing how bright the LED is. This is called pulse width. So I stop this here. So I have interrupted it from the keyboard. Now we do the same code. And we say P25 on. And then we sleep much shorter, 0.01. This is 10 milliseconds. And then we switch it off. And then we sleep for 0.01 second. So it's half of the time on and half of the time off, but it's so fast that our eye can't see it, and what you see it's just not as bright as it would be on the whole time. We do one more try where we do the on time much shorter, and you will see that it's not as bright as before, and this is a way of changing how bright the output is. So okay, I have to disconnect here. I think I disconnected here. I reboot it. So what we see now, it's rebooting. It first goes into the access point mode, but as it already knows the Wi-Fi I'm developing in, we get the connectivity. Now we see it's back at this, and we can connect it. And now we have it. And now let's do this again. So I think we first have to, before we do this, we have to set the pins. So I copy this in. So we have now the pin, and now we can say P25 is equal pin 25 and pin dot out. And now we can say P25 on, just to check if it works, and we have it. And now we can try this with the loop. While true, we have got this capital, which I don't want. So while true, now we say P25 dot on, sleep 0.01, or let's put one more zero in, so it's now only a thousandth of a second on, and then we say P25 off, and now we say sleep for 0.05 seconds, so it's longer off than on. And now let's see, have a quick look. The LED gets less bright, but it's not off. And you can see it at this level, see it's still flickering. If we would go faster, then you would not see the flickering, you would just see that the LED is less bright. And for this there's a built-in function which is called pulse width modulation, and we have a look at this later because we also need this for running servos.